Welcome to the slope of parallel and perpendicular lines refresher. So today we are answering the question, are these lines parallel, perpendicular, or neither? Remember that parallel lines have equal slopes, or we could also say that they have the same slopes. In my first example here, I have a set of lines and they are written out in slope-intercept form, which we usually refer to as y equals mx plus b. So the m is always going to be the number in front of x, and m is the letter that stands for slope. So my first equation is y equals negative 2x minus 9. My second equation, y equals negative 2x plus 4. The negative 2 is the slope. It is the same in both, so those lines are parallel. Now it's very common that we end up getting sets of lines that are not in slope-intercept form. So what we need to do is convert. So in order to convert into slope-intercept form, we are solving for y. So my first equation, 3y minus 4x equals 12. I start by adding 4 to both sides. Remember that 12 and 4x are not like terms, so they cannot combine to make 16x. So in my second step, I see I have 3y equals 4x plus 12. And now in order to solve for y, I must divide everything by 3. And so I end up with y equals 4/3 x plus 4. And the 4/3 is my slope. In my second equation, I have negative 12x plus 9y equals 81. So I start by adding 12x to both sides, divide everything by 9, and then my equation is y equals 4/3 x plus 9. So because I have 4/3 for the slope in both equations, those lines are parallel. So let's look at the x equals lines next. I have x equals 5 and x equals negative 2. A way to remember what to do with x equals lines is the acronym VUX. Vertical lines have undefined slope and they are x equals. So your x equals lines are vertical, which we can see in our graph. We have x equals negative 2, x equals positive 5, and they're both vertical, so they're going to be parallel. And lastly, we have sets of points. So with these, we're going to use our slope formula to find out what the slope is of the line that contains those points, and then we can compare them, and if they are the same, like here, the slope of line A and the slope of line B are both 3/2, that means we have parallel lines. Perpendicular lines have slopes that are negative reciprocals. So reciprocals are when you flip a fraction over, and when they say negative, they mean one is positive and the other one is negative. So again, my first set of equations is using slope-intercept form. So we're looking at the number in front of the x. In my first equation, I have y equals 2/3 x minus 12. In my second equation, I have y equals negative 3/2 x plus 8. So the 2/3 from the first equation is flipped over, and that would be 3/2 that we see in the second equation. The first one is positive, the second one is negative, so these lines are perpendicular. And so here we have a set of equations where we need to convert into slope-intercept form again. So we're solving for y. I need y by itself on the left. So when x plus y equals 5, I subtract x from both sides, and that's it. Then I have y equals negative x plus 5. And in the second equation, y minus x equals 6. I add x to both sides and end up with y equals x plus 6. So with these lines here, I have a negative in front of the x, and here there's nothing in front of the x. That means that there's that technical 1 that should be there. So I could look at the first equation as having a slope of negative 1/1, and the second equation as having a positive 1/1. So if I were to find the reciprocal of 1/1, it would still be the same thing. So since I have one positive and the other one negative, I know that these lines are perpendicular. But I would like to talk about what the theorem actually states when you have perpendicular lines, and that's that the product of your slopes equals -1. So in my first equation, I have -1, and in my second equation, I have 1 as my slopes. So is -1 times 1 -1? Absolutely. That's why we like to look for reciprocals, because in the first example, I had 2/3 and negative 3/2, and if I multiply those together, I'm getting 6/6, and it was negative, and when I reduce that, I still get -1. So the actual theorem says to look for slopes that equal -1 when you multiply them together But a quick and simple way to look at slopes to see if they're perpendicular without doing a calculation is to search for your negative reciprocals. Now, when we get to x equals and y equals lines, remember VUX for x equals lines, vertical undefined x equals. So we know that x equals lines are vertical. And then when it comes to y equals lines, we have HOY. They're horizontal, they have a zero slope, and they are y equals lines. So my graph shows what they would look like. I have x equals 5, which is a vertical line, and then I have y equals -2, which is a horizontal line. And they're meeting right here and forming a 90-degree angle, so those lines are perpendicular. So anytime you see a set of lines and one is x equals and the other one is y equals, you have perpendicular lines. Then we have the set of points. So remember, we are using our slope formula, so you can plug in your x and y values into there and then evaluate. In line A, we're getting 4 over -3, so we can call that -4/3. And in line B, we're getting positive 3 over 4. So those are negative reciprocals. We have perpendicular lines. Now, the last thing that we can encounter is neither. And if a line gets categorized as neither, it means that the slopes are not the same and they are not negative reciprocals. So for example, here are a pair of lines in slope-intercept form. We have y equals 2/3 x minus 4. And y equals 3/2 x plus 2. So remember, it's the number in front of x that tells us the slope. They are reciprocals, but they're both positive. So these are not going to be perpendicular lines. They're not the same or equal to each other, so they are not parallel. So here's an example where we have lines that are not in slope-intercept form. So we had to first convert them. In x plus y equals 7, I just subtracted x from both sides. In 2x plus 4y equals 8, I had to subtract 2x and then divide everything by 4. So from my first equation, I'm getting that I have a slope of -1. And in my second equation, I'm getting that I have a slope of -1/2. So we're not seeing negative reciprocals. They're not equal. These lines are neither parallel nor perpendicular. And then in my example, I have x equals 5 again, so that's a vertical line. But then I have y equals 2x plus 1. So this other line here is not vertical, so it will not be parallel to the first line. It's not horizontal, so it cannot be perpendicular to the first line. This would be an example of neither. And now if my graph were to continue, we would eventually see somewhere that the x equals 5 line intersects with y equals -2x plus 1. So these lines are neither parallel nor perpendicular. And lastly, we have our example with the points on the line. So again, we use the slope formula. And for line A, once I put my values in and evaluate, I'm getting a slope of +1. In line B, I'm getting a slope of 0. So again, because the slopes are not equal, they're not negative reciprocals of each other, they are not parallel or perpendicular. And that concludes our parallel, perpendicular, or neither refresher.